The standard normal distribution. I discussed the normal distribution and some of its properties in a previous video. The standard normal distribution is a special case of a normal distribution. I recommend you watch my previous video first if you have not already done so. The standard normal distribution has a symmetrical and bell-shaped density curve. As the horizontal axis represents the z-values, z-scores refer to the values on the horizontal axis. This curve must also meet the properties of a density curve. The curve should be above O on the horizontal axis and the area under the curve should be 1. As you see here, the density curve is symmetric around the 0. Therefore, the mean of the standard normal distribution is 0. How about the sigma, the standard deviation? It is 1. Since the horizontal axis represents the z-scores, we can write z as a normal distribution with mean 0 and the standard deviation 1. Now let me compare this with the general case. Yes, you see the difference between the horizontal axis. The general case, we use the random variable. Here we use x random variable. So values on the horizontal axis depend on the values of the x. And same, the mean and sigma are also depend on the value of x. But in the standard normal distribution case, the mean is always 0 and the standard deviation is always 1. Therefore, the normal distribution with mean 0 and the standard deviation 1 is called the standard normal distribution. Now let me talk about some properties of this one. The cumulative area is close to 0 for z-scores close to negative 3.49. The cumulative area increases as the z-scores increases. As you see here, the z-values increases on the horizontal axis from left to right. The cumulative area for z equals 0 is 0.5. In a symmetric distribution, the mean, mode, and the median must be the same. Therefore, these three components of the standard normal distribution are 0. The cumulative area is close to 1 for z-scores close to 3.49. Now let me talk about the standard normal table. The table has two sides. The first column on one side contains negative numbers, while the first column on the other side contains positive numbers. At the top of the table, you will find the density curve of the standard normal distribution. The z-scores are located on the horizontal axis of the density curve. The standard normal distribution has a mean of 0, so negative z-scores are left of the mean and the positive z-scores are right of the mean. The number with 4 decimal places represent the area left to the z-values. Now let's take a look at the negative side. The first column and the first row provide the z-scores, whereas the number with 4 decimal places represent the area left to the z-value. It is the same on the other side, but z-scores are positive. You see, here also gives the area under the curve and left to the z-value. Area also can be referred as a probabilities. I will now explain how to use a z-table to calculate the area of probability. There are three possible cases here. First, the area left of the z-values. Second, find the area to the right of z-score. And finally, find the area between two z-scores. Now let me explain this using some examples. First, to find the area to the left of z. The example, find the area to the left of z equal 1.26. That means we need to consider the standard normal distribution, because here we have z value, and mark the z value on the horizontal axis and consider the area under the curve and left to the 1.26. Since the standard normal table gives the probability or areas under the curve and the left to the z value, we can use the z table directly. Therefore, go to the 1.26 and find the corresponding probability. It is 0.8962. Therefore, the area to the left of z 1.26 is 0.8962. Again, when you have the area, or when you need to find the area left to a z value, you can directly use the z table. Now let me explain how to find the area to the right of z 1.26. Now we need to consider the area right to the 1.26. Can we find the area directly from the table, a right area? No. Why? As I mentioned before, the table always gives the left area left to the z value. Now how do we find the area right to the z value? We know the total area, entire area, and also we can use the table to find the area left to the z value. Then subtract. Then you can get the area right to the z value. So what is the entire area? It is 1. Therefore 1 minus, and we already know the area left to the 1.26 by the example we discussed before, that is 0.8962. Therefore area right to the 1.26 is 0.1038. Then understand this. When you are looking for the area right to a z value, you always find the area left to the z value and subtract from 1. Now let me talk about the final case. That is the area between two z values. That means the area here between -80 and 1.26. How do we find this area? Yes, let me explain this way. What is the highest number here? 1.26. Therefore, first find the area left to the highest number, highest z-score. That is 1.26 here. We already know that area. That is 0.8962. Then find the area left to the smallest z value. Here smallest value is -0.80. We don't know this value, so let me find this. Then once we have that value, we subtract. Then we can have the area between these two z values. Now we need to find the area left to the -0.80. Since we have a table, z table, and gives the area left to the z value, we can go to the z table and find the corresponding probability. It is 0.2119. So we can subtract that from 0.896 the answer is 0.6843. In my next videos, I am going to explain more examples.